Okay, next up we have another factoring question. So let's go ahead and deal with this. So I would like to now factor 2x squared plus 3x plus 1. So as I mentioned, typically I have two ways to answer this question. I could use product sum or I could use the quadratic formula. Now I need to make a note here that product sum becomes not tricky, but it's easier to end up wrong in the scenario where my coefficient a is non-zero, because product sum is going to give you two numbers. Let's call them m and n, and what you're going to put in for those two numbers as the solution. Typically, what you're used to doing when you use product sum is just putting in x plus m and x plus n. But as we know, if I multiply these two x's, I'm just going to be left with an x squared. So it's easy to forget that you had a non-1 coefficient before the x squared. So the best method to use when you do end up with this is a quadratic formula. It's guaranteed to give you the correct answer. I don't need to think about what the coefficient in front of the x squared is. I can just go for it. So first we're going to apply that method, and then I'm going to show you how to use it with product sum, and lastly the one that is done below here. So with the quadratic formula, I need to remember ax squared plus bx plus c. Quadratic formula states that it's negative b plus or minus the square root of b squared minus 4ac. And this is all going to be over 2a. So let's go ahead and plug in our values. I have a is equal to 2, b is equal to 3, and c is equal to 1. So when I plug that all in, I get negative 3 plus or minus the square root of 9, because that's 3 squared, minus 4 into 2 into 1. And that's all going to be over 2 by 2, which is 4. So let's go ahead and simplify this to become negative 3 plus or minus the square root of 9 minus 8, because 4 by 2 is 8, by 1 still remaining with 8. So 9 minus 8 is going to give us a 1. So the square root of 1 over 4. Square root of 1, we know is just equal to 1, because 1 squared is 1. So this would become, my two answers would be negative 3 plus 1 over 4. That becomes negative 2 over 4, which is negative 1 over 2. And for my second answer, so this is equal to x1. For my second answer, I have negative 3 minus 1 over 4, which is going to give me negative 4 over 4, and that is simply going to give me negative 1, and this is going to be my x2. Recall with the quadratic formula, it's giving you x is equal to whatever it spits out. So I need to move everything to one side so that can be equal to 0, and that's going to give me my 0. So this x1, so x1 is equal to negative 1 over 2. When I rewrite it, it will become x plus 1 over 2 is equal to 0. And for my second one, I have x2 is equal to negative 1. When I rewrite it, it will become x plus 1 is equal to 0. Now, I already knew that I'd end up with a fraction here because, as I just said, it gives you x is equal to whatever it is, not 2x, not 3x. It does account for the coefficient in the formula itself, but in the final answer, it'll give you it in this form. And I typically would not like it in this form. Instead, I would like it with whole numbers in this position. So I can rewrite x plus 1 over 2 is equal to 0 by multiplying the entire thing by 2. And this will give me 2x plus 1 is equal to 0. That way my two solutions are 2x plus 1 and x plus 1 is equal to 0. And I can tell when I multiply the 2x by x, I get the 2x squared that I was expecting. And so we can just double check that this is correct. Do your FOIL. And you get 2x squared plus 2x plus x plus 1. Giving me 2x squared plus 3x plus 1. And so using quadratic formula does give you the right answer, as I said before. Now let's use a couple other methods that are a bit more straightforward for when you're trying to find the answer very, very quickly, which is typically when this is just an intermediate step in a larger calculation, which it typically will be when you get to the university level. Because this would not be the point. The point is that you know how to use this to get whatever it is that you're looking for in the question. So for our second method, we're going to use product sum. So recall AC, B. AC is going to give me 2, and B is 3. And so I want two numbers that when I multiply them, I get 2, and when I add them, I get 3. My factors of 2 are 2 by 1. So I can just put in those two numbers, 2 and 1, because 2 plus 1 is 3, 2 by 1 is 2. And so it works. And so now I need to figure out which one goes with the 2x, because I know I have 2x plus one of them, and I have 2x with the other one. So this is where I need to be careful, because if you match them incorrectly, which isn't possible when you have an a of 1, you'll get the wrong answer when you expand it back out, and you will get the wrong answer. So we can start by trying in 2, for example. So 2x plus 2 multiplied, my apologies, the other factor is x plus 1. Okay, now when I do this, I can already tell this is wrong, because if I divide out the common factor of 2 here, I'm going to get 2 by x plus 1 by x plus 1, which is 2x plus 1 squared. This is obviously not correct, because x plus 1 squared is going to give me x squared plus 2x plus 1. That multiplied by 2 is not going to give me what I'm looking for. It's going to give me 4x here instead of the 3x that I need. So I can already tell this is wrong. And so now let's try and reverse it. And instead place the 1 with the 2x, which, if you've already done the quadratic, as I did before, you would already know that it's the correct answer. So now I have 2x plus 1, x plus 2. Yeah. Sorry, just one moment. Now let's divide out the 2. Yeah. Yeah, so let's divide out the 2 now to leave me with x plus 1 over 2. And x plus 2, which is not what I was looking for, because what I was looking for was x plus 1 over 2 multiplied by x plus 1. And so I can already tell you right here, product sum is not the best method to use when you have an a that is non-1. So let's go about checking a different method. Okay, and so for this third method, it's derived off of the quadratic formula, and what we're going to do is we are going to be making use of so if you recall, when I multiplied these out, I got 2x squared plus 2x plus x plus 1. So what I'm going to do is I'm going to try and get what I have into this form that's easier to factor visually without going through the quadratic formula. So when I have 2x squared plus 3x plus 1, how I usually do that is I would like to rewrite this in a form of ax squared plus bx plus cx plus d, such that a by c is equal to b by d. And the best choice here when I split this 3x is going to be 2x squared plus 2x plus x plus 1. So that over x squared, a by c. Yeah, so 2 by 1 is equal to 2, the coefficient here, and 2 by 1 is equal to 2. So I have satisfied this. And so I have split it correctly, and then next up I'm going to factor just by common factors, and I'm going to split it along this line. And so first I factor this plus whatever factor I get for this. And so for this first half, if I factor out 2x and leave in x plus 1, that's going to be the correct factorization for here. For here, there's nothing to factor out, so I'm just going to leave it with plus 1 and x plus 1. Typically, you'll want to factor it such that these two brackets are the same. That way, it becomes an application of FOIL, and I can tell that this is the same as 2x plus 1 multiplied by x plus 1. And so, use quadratic if you're not quite good at doing it this way and you have the time. Okay? Use the splitting method if you don't have the time and would just like to do it quickly and you're familiar with factoring such that you can easily FOIL to check your answer or visually inspect to check your answer. But the final answer is going to be x plus 1 multiplied by 2x plus 1.